All right, well, thank you very much. I do appreciate that. And again, a big thank you for this organization, this church, for Pete and Diana for flying me in here to give this talk, and also for Frank, because he's doing something that is quite impressive. He's doing something that Dr. Thomas Chamberlain, he'd be really impressed with. He said you should always have multiple working hypotheses. So then you can sharpen your analytical skills, you can compare and contrast, you can reduce biases. He says otherwise you just memorize and conform. And so I do thank you, Frank, for allowing this venue to look at two different theories, and hopefully we'll move science down the lane. And then the other one, I'm from Minnesota, and it's with great pleasure I can come here and say thank you, Texas, along with Florida and South Dakota, who led us to freedom back when they were trying to lock us up. But that battle's not over. I don't know if you heard about what happened on Saturday in the middle of the night. They gave Tedros the authority to call the next pandemic. And so you can check that. So we need to be aware of what the powers that be are doing. And you just need to be aware. And also Washington, D.C., the Department of Education, they're telling us how to think about the past. They give us a blind chance, random collisions of atoms perspective of the past with the Big Bang and evolution. And that's with their Department of Education, and that's the only way you can look at it. But their perspective is all wrong, because these are just screenshots from secular journals. Researchers want to know, unexpected, fossil oddity, long-standing puzzle. I totally didn't believe it. It shouldn't exist. Scientists puzzled. Double-ended mystery, surprising features, unanswered questions, hard to believe, world of surprises, major mysteries, wrong directions. Puzzle scientists, puzzled students. Why are they puzzled? Because they have the wrong perspective of the past. Blind chance doesn't bring us this. A creator brings us this. And so if you start with a secular model, you're going to have mixed up ideas. And I'm here to present a biblical model. And does anybody know what that is? Anybody? Brianna probably does. Yeah, what is it, Brianna? Yeah, a bear climbing up the other side of the tree. Can you see that now? Okay, yeah, and so there were some seemingly unrelated data points there, lines and circles, but then you give it a picture and it comes together in one coherent picture. And that's what we're going to do with the hydroplate, because we've got answers to scientific problems, and we had all those, there's a lot of them. We're going to go through a lot of those problems, and we had our very first hydroplate conference last year in September. And you can watch it online at hydroplate.org or on Rumble or on YouTube. And we had 3 PhD scientists speaking. And one of them was a professor of astronautics from the U.S. Air Force Academy. So there's some very well educated, very prestigious people who think this is a good theory. The hydroplate has the answers, but if you don't know what the questions are or what the mysteries are, it's not going to matter. So we're going to run through a few of them. What mechanism would cause a large volume of low-standing continents to rise rapidly a mile in the air? This is the plateau mystery. We have then a double-ended mystery. For the Colorado Plateau seems to have grown downward at the same time that its emerged part rose upward. So that's a double mystery. And then why is the crust missing in the mid-Atlantic? This is from Science Daily. It says the Earth's crust missing in the mid-Atlantic. Mantle is exposed on the seafloor, and it was as if it was never there. So then how and why? But if it was there and torn away, if so, how and why? And what caused the Ice Age? And once it started, why did it stop? And this is from Nature. They're puzzled. Perhaps the longest standing puzzle in the earth sciences is what caused the northern hemisphere's ice sheets to come and go. And how do redwood trees grow where it's dark 4 months of the year? This is from Science Daily. Fossil oddity, giant redwoods near the North Pole. They say they're 45 million years old. And it was covered in a forest in the permafrost. I don't buy that one. And it's a challenging mystery, because how can trees grow when it's dark 4 months of the year? And then it said these fossils are chemically preserved at a level you usually would expect to see in something that's only 1,000 years old. Not millions, 1,000. Scientifically, that's what it shows. And then Discover Magazine talks about the greatest unanswered questions of physics, and number 3 is, how were the heavy elements from iron to uranium made? They don't know that. And Walt Brown doesn't think that there was uranium during creation, because God said everything was very good. Is it good to have uranium, which can cause birth defects? And so he thinks it was made during the flood, and that's just foreshadowing a little bit. This is from Science. It says, we're all made of star stuff. The problem is physicists aren't quite sure how stars did it. And then why is the moon rusting? This is from NASA. The moon is rusting, and researchers want to know why. While the moon is airless, They find hematite up there, a form of rust that normally requires oxygen and water. That has scientists puzzled. It's very puzzling. The moon is a terrible environment for hematite to form in. Yeah, if you believe in blind chance and random collisions, yeah, it's a terrible environment. But if you, and that says, I totally didn't believe it. It shouldn't exist based on the conditions present on the moon. But the hydroplate will answer it. Then why are rounded boulders on comet 67P? Because when things slam together in space, they're going to have jagged edges. The only way you get rounded things is if it's going through a fast flow of water before they go up there. Well, how could that happen? And this is from Science. It says one of the most surprising features discovered is nodules. They call them dinosaur eggs or goosebumps. Rounded boulders on that comet. And this comet, this is Science comet, close-up reveals a world of surprises. I find it hard to believe that at the present time 67P was originally homogeneous. Comet-forming regions of the early solar system were more turbulent and chemically diverse than theorists have thought. So the theorists were wrong. You know, one experiment is worth 1,000 expert opinions. Just remember that one. And how do you get peanut-shaped asteroids? You know, this is a major mystery, how two objects, each the size of skyscrapers, could collide without blowing each other to smithereens. This is especially puzzling in a region of the solar system where gravitational forces would normally involve collision speeds of 4,500 miles an hour. Now, how is that going to happen? Then you got these peanut-shaped asteroids, and one of them has a moon. How did peanut-shaped asteroid 624 Hector get a moon? And it talks about it's a mystery. The formation of the system made a dual primary, and a small moon is still a mystery. Catching a moon is really difficult, because if two objects are coming together, they're either going to slam into each other or they're going to slingshot around each other. Catching a moon is really, I mean, they can't even explain how we got our own moon. They got 4 theories, and none of them work, so one of the professors says the best explanation for the moon is observational error. It doesn't exist. And he's kind of tongue-in-cheek saying that. And why is Nike orbiting backwards? It's a weird orbit, puzzles scientists. And from phys.org, beyond Neptune, a chunk of ice is orbiting the sun in the wrong direction. That's because your perspective of the past is wrong. Okay, those were all secular journals. They all had big questions. Now let's just do some random questions. Yeah, Mount Everest, this is NASA. What causes a mountain to rise? You know, what's the mechanism, the energy, and the force? And how do marine fossils get way up there? And NASA writes, the presence of limestone and ocean marine fossils at the top of the mountains is one of the key pieces of evidence cited that advanced the idea of plate tectonics. So plate tectonics was put in place to explain the fossils on Mount Everest. So plate tectonics, that's a secular model. Catastrophic plate tectonics is a secular model sped up. It's kind of like evolution is a secular model. And theistic evolution is a secular model with Jesus slapped on it. And so we should be very careful about taking our models from our government, their models. Okay, and how did Mariana Trench form 7 miles below the sea level? How did that happen? And why are trenches mainly in the Pacific and not in the other oceans? And why is it so much different in the Pacific? And why does it have 40,000 volcanoes with table mounts and sea mounts? And how did the mid-oceanic ridge form? You know, that's a 46,000-mile mountain range that circumnavigates the globe at the bottom of the ocean. It'd be the 8th wonder of the world if people knew it was there, but it's buried underwater. And that mountain range is made by stretching it in 2 directions. See, when rock is compressed, it gets a bunch of crinkly, lines, cracks. But when it's stretched, when the pressure releases, you get a straight crack. And this is what you have. You have vertical and horizontal cracks. So it's being stretched in 2 directions. And why are mountain ranges parallel to the mid-Atlantic ridge? And what caused inland seas to form? And they know. And I thought, how do you know they're inland seas? On the Gulf of Mexico, the Mediterranean? Because there's a whole bunch of salt at the bottom, along with the Black Sea and the Caspian Sea. Well, how did all that salt get down there? And we were paging through Walt's book, and there's the Gulf of Mexico, and my wife said, hey, that's going to be close to where you're speaking. And I've never heard anybody talk on this. These are the salt layers. This is under the Gulf of Mexico is a single salt layer called the mother salt layer. It is at least 20,000 feet below sea level, 100,000 square miles in area, and 1,000 feet thick. Many tall salt domes have risen several miles above the mother salt layer. Some salt domes are taller than Mount Everest. How does that happen? How does all that salt get down there? And then it says, sediments almost 30,000 feet thick were then deposited on top of the 1,000-foot thick mother salt layer. How did that happen? And this is your salt dome. You know, and so my biggest question in August is, hey, how did all that salt get down there? How did it get all covered with sediment, and then it got to rise, guys got to rise through that loose sediment? And that's I don't know, that's going to be interesting in August. Okay, and then how did the 90 East Ridge form? That's a ridge that's 3,100 miles long by 120 miles wide, and it's perfectly straight. And why does it point at the Himalayas? And then where did all the sediment come from that averages a mile deep on the continents? You ever wondered about that? What eroded all that sediment for the sedimentary rocks? And the ratio, if it doesn't have limestone in it, or doesn't have carbon in it like limestone, the ratio is 65 parts granite and 35 parts basalt. Why more granite than basalt? And basalt's mainly the ocean sediment. You know, the basement rock of the oceans. How did that get on the continents? Tough questions. Okay, and let's see. And what caused it to be so evenly mixed with a cementing agent like calcium carbonate and quartz? Quartz is key. Quartz is in granite. We're going to come back to that. But those sand dunes, are they turning into stone? No, they're just blowing around. The only way they get turned into stone is if it's mixed with a cementing agent. And you've got cementing agent all over the world, turning all this sediment into sedimentary rock. And this is the Zuni mega sequence that goes all over the continent. And I was talking to a student at St. Cloud State, and I was trying it's like, there was a worldwide flood. And he goes, he didn't think so. And I said, well, you explain. How do you get a continent-wide layer of sediment? And he said, mudslides. You know, I don't think so. Well, how do you get seashells in the mud then? But these layers, they go all around the world. Tim Clary's doing a great job for ICR looking at the boreholes, and it's like it's all over the world, worldwide layers of sedimentary rock. And I like how Answers in Genesis explains this. Global evidences of the Genesis flood, and in there, right, it's talking about the cliffs of Dover and the cliffs of Normandy. These same chalk beds can be traced across France, the Netherlands, Germany, Poland, southern Scandinavia, and other parts of Europe to Turkey, then to Israel and Egypt, and as far as Kazakhstan. Remarkably, the same chalk beds with the same fossils and the same distinctive layers above and below them are also found from Nebraska to Texas and from Alabama and Arkansas to Colorado. And they also appear in Australia. Those chalk cliffs go everywhere, and you can't lay that down with a local flood. And then how do flat layers form under slanted layers in the Grand Canyon? You got slanted layers underneath the flat layers. Why would that be? And speaking of Grand Canyon, why did the Colorado River flow through the plateau instead of around it? You know, those elevation maps, it clearly should have flowed around it, and yet it flows right through it. How does that happen? And then where did all the limestone come from? Walt Brown, he used to meet with Bob Dietz. He's the guy who coined the term seafloor spreading, so he knows a lot about geology. And they'd meet at Arizona State, and Walt asked him one time, you know, because when limestone forms, it releases carbon dioxide. And there's 60,000 times more limestone on the surface of the earth than in the atmosphere. So Walt asked Bob, where did the limestone come from? And Bob says, beats the blank out of me. You can't explain it. So there's a lot of mysteries there. And then there's this 5 to 10 ton quartzite rock that got lifted up into the sedimentary layers. How does that happen with your Big Bang Theory? And those are two of Walt's grandsons, and don't try this unless you're in excellent shape. I think it's a day or two hike down there. But that's a real hard thing for the gradual, uniform, millions of years thing to explain. And what force crushes granite? This is the Gunnison Canyon, or more specifically the Black Canyon of the Gunnison River. Yeah, those are compression cracks. Remember we talked about tension cracks being straight? These are compression cracks like marble cake. And to give it scale, those are on the top there, those are 5 to 10 foot trees. So this is a lot of granite that got crushed. And this goes for 50 miles. What has enough force to crush 50 miles of granite like that? And then it also did the same thing at the bottom of Grand Canyon. The inner gorge has the same type of compression cracks in the Vishnu schist. And how did mesas, buttes, and spires form? And how did petrified trees form? And how did canyons form under the ocean? These are submarine canyons, and a lot of the major rivers have major canyons cutting through on the continental shelf, but it's below the ocean. The one at the Congo is twice as long as the Grand Canyon. And so how does that happen? And also in Greenland, there's a canyon cut by a river under 2 miles of ice. How'd that happen? And then in Antarctica, they got lakes under 2 miles of ice. How about that? And they're liquid. And if you deny deny the worldwide flood, you got to figure out a way to cool down Antarctica to make liquid lakes. And that's going to be tough because the average summer temp is less than freezing. Okay, and then this says the South Pole is covered by ice, but fossils show that crocodiles, dinosaurs, and palm trees once lived on that land. How are you going to get palm trees to grow where it's dark 4 months of the year? And then on the other side of the world, up in the Arctic Circle, they find fossils of snakes, tortoises, alligators, badgers, shrews. They can't live in permafrost. How'd they get there? And also those redwoods we talked about, but let's just see the size of them. They're 98 feet to 131 feet long, and they got a 10-foot diameter. Those are big trees. And they ain't growing there if it's dark 4 months of the year. And then what froze the mammoths? The mammoths, it's a misnomer. They call them woolly mammoths, but it's not wool, it's hair. And they don't have erector muscles or oil glands to make it warm. And there's no way they can live in the Arctic. Do you guys get cold noses in the winter here at all? Does it ever get that cold? Okay, well just think if your nose was 6 feet long. You know, it's not gonna work. And also they eat too much. They eat too much, they drink too much. There's no way they're living up in the Arctic. They're a temperate animal. So how did they freeze and how did they get up there? Okay, and what froze the mammoths? Again, this one here was frozen standing up. Any deer hunters out there? Anybody hunt their deers? What happens when you shoot them? They tip over, yeah. And then what do you do? Eat them. But before that, before you eat them, you gut them. Yeah, you take the gut out so that heat goes out of there. That heat's going to destroy the meat. Well, that didn't happen with this one. It still had identifiable food in its stomach and its mouth, and it was summer food. And so it was flash frozen. They figured 150 degrees below zero, and it just, boom, how did that happen? And then how did it get so cold so fast during the summer to freeze them? And then once it froze, how come it didn't thaw out? Tough questions. And then why were there no glaciers in parts of Alaska? If you look in the upper left corner there, that yellow part, that's the land bridge between Alaska and Russia. I always thought it was the Aleutian Islands, that was the land bridge, nice and narrow, but this is big, big, wide land bridge. And then the brown part up there, didn't have a glacier. So it's the Ice Age, and you don't have a glacier in parts of Alaska or Siberia, where there's permafrost today. You didn't have a glacier during the Ice Age. And how come how can we find stuff from Earth in the comets? You find water, salt, silicates, limestone, cubonite, all that stuff. Oh, cubonite, that's a good one. Let's look at cubonite. That cubonite forms only in the presence of scalding hot water. How do you get scalding hot water in space? And it says liquid water can't reach those extremely hot temperatures in comets' low pressure environment. Indeed, even cold liquid water inside comets will instantly flash into steam. So how are you going to form something in scalding hot water? Then why is there sea plankton found on the outer surface of the International Space Station? Plankton, how does that get up there? And then this one, how does an asteroid get moons? We talked about that. And chondrules, how does that form in meteorites? And you're thinking, what's a chondrule? That's what I thought, so I looked it up. And whatever it is, it's formed at high temperatures. And how the chondrules were melted, however, is not understood, so they're still puzzled based on their blind chance theory. But you have high energy events such as high velocity collisions and splashed about as droplets that quickly cooled and crystallize. So high impacts, quick cooling. What's going to cause that? And then why does Pluto look so young? They figured it would look, that was a prediction on the left, it was going to look all old and beat up, but it looks pristine. Why is that? And then why is the far side of the moon so much different than the near side? Because the far side's pretty white there, there's no lava flows or moonquakes, but the near side, man, look at all those lava flows, that's the dark area. The near side of the moon got pounded. You know, the far side got peppered. There's high density impacts, I think, on this side. And it's counterintuitive because the Earth protects the near side of the moon. And when you throw the Earth's gravity in there, it's going to be really hard to have a direct hit on the near side. And yet the near side is the side that's pounded. And does anybody know where where Earth's oldest rock was found? Anybody know? It was found on the moon. How does a rock get to the moon? And it must just be covered with Earth rocks there because you just picked up at random and brought it back. And yeah, it was found on the moon, and it says it was crystallized about 20 kilometers beneath Earth's surface in a water-rich environment. How are you going to get a rock 12 miles deep onto the moon in a water-rich environment? And then why do nearly all short-period comets go in the same direction as the Earth? Because if the comets came from the Oort cloud, it should be a 50-50 mix. Some going prograde with the Earth, some going retrograde against the Earth, but it's not. It's 97% in the direction of the Earth. So my guess is the comets have something to do with the Earth. Okay, and so we asked a lot of questions and a lot of seemingly unrelated topics. But I submit to you that the hydroplate answers every one of them. Logically, coherently, you say, oh yeah, I can explain that. And so the hydroplate, as Frank mentioned, it was developed by Dr. Walt Brown. He went to West Point. He was an Army Ranger, paratrooper, went to MIT and got his PhD in mechanical engineering. So he's looking at the Earth, there's mechanisms and forces and energy budgets. How is this all going to work? Which is a good way to look at the Earth, I think. And then he ran the Benet Military Lab, where he had dozens of scientists, PhDs working for him, and like 100 scientists. So he's a really sharp guy. He did, the U.S. Air Force Academy wanted him to teach there, so he did. And yeah, it's just phenomenal. And that's not what impresses me about him. I don't care about the letters behind your name. I don't care what you've done here or done there. He makes accurate predictions. Some of them are astoundingly accurate predictions that just drops the jaw of the secularists. I was invited into a class, believe it or not, to share my thoughts. The professor said, you got 15 minutes once the kids get here. And so I said what I did, and it was done in 10 minutes. Any questions? And the professor said, well, what would you do if you were king of science for a day? I said we'd put all the theories on the table, and we'd focus on the one that makes accurate predictions. Plus, we won't teach belief systems about the past, like the Big Bang and evolution. That's got nothing to do with science, because science is observation and testing. And so then there's Walt Brown. And the 8th edition, it used to be a $30 book. The last one on Amazon went for our $280. And we got 16 of them here tonight for $50. So if anybody wants to get one that you can hold in your hands, this is the 8th edition, copyright 2019. Or no, it's 2009. The 9th edition, copyright 2019, is on DVD. I can show you how to download a PDF for free. Okay, but it's neat to have the book, because then you can go hydroplate surfing. Because you look about that, and it'll give you a reference to another thing, and all the ideas kind of flow together. And so this is available for $50. I think it's for a limited time. And this astronaut thought so much of it, he brought it into space and took a picture of it on a disc, and then he presented it to Walt Brown. So there's very highly educated people who understand this. I went into St. Cloud State, and I went to the Earth Science Department, and I met a professor, and I said, you guys don't have a theory for Grand Canyon that works. Do you want to see a theory that works? And to her credit, she said yes. So I let her have my book for at least 6 months, and then we got together, and we talked about it for about an hour and a half, and she said, if the assumption is true, the science works. I just don't believe the assumption is true. Okay? So what I'm about to show you has been rubber stamped, or it's been verified by a college professor. If the assumption is true. So what's the assumption? At least half of the ocean was inside the Earth at one point in time, 60 miles deep under granite. That's the only assumption. How it got there is not part of the theory. So just think of the Earth as a big apple with the apple skin 60 miles thick, made of granite, and then there's a layer of water about a mile thick, and then there's basalt underneath that. That's it. And then let the laws of physics go at it. How do you do that? You throw the moon in there, because the moon tugs on the Earth twice. You get high tide and low tide twice a day. Well, back then it's tugging on the crust of the Earth, and the crust wasn't broken into plates like it is today. It was just the crust. So the crust stretched and compressed, stretched and compressed, stretched and compressed, and generated heat. Like if I had a wire up here, bend it back and forth, it's going to get hotter and hotter. That's what happened with the crust. The heat went into the water. The water got hotter and hotter. And it wants to boil. It's hot enough, but there's no room to expand, and it can't boil. So at 705 degrees and 3,200 psi, it becomes supercritical water. And they understood this in 1822, but they didn't know what it was. You know, when you put pressure on top of the lid, it'll boil at 212, but if you cap it and keep it pressurized and keep getting it hotter and hotter and hotter, again, 705 degrees, 3,200 psi, it's supercritical. What is it? And then in 2005, they finally figured it out. They said it's both. It's water and vapor. It's microscopic drops of water suspended in air. This is when the liquid density equals the gas density. And whatever it is, that's what it is, and it dissolves things like crazy. That's the key. So it's dissolving the granite above, and remember there's quartz in the granite, and it's dissolving the basalt beneath. And it's putting together all these minerals like limestone and chalk and quartz and salt, and quartz is a key one there. And so and then I think it precipitates out of the water at about 800 degrees, the salt does. So you're getting these layers of salt and minerals at the bottom of the subterranean chambers. And so those are building up and building up. It's getting hotter and hotter. The crust is getting weaker and weaker, and pretty soon there's over 300,000 psi in that subterranean chamber. And when there's a crack on the crust of the Earth, it's going to erupt out of there. It's going to go in two directions at 2 to 3 miles per second, and it's going to circumnavigate the globe in a few hours. And the water's just going to erupt out of there from over 300,000 psi to almost zero at the atmosphere. It's just going to poof. And that's how it could rain for 40 days and 40 nights. And then people say, well, if that happened, wouldn't it leave a mark on the Earth? The answer is yes, it did. It's called the mid-oceanic ridge. That's what happened. That's the mark it left. And if you see that circle there, Wolf thinks that's where the crack ended, because the crack from the Pacific got there first, and then the crack from the Atlantic got there and hit that and stopped going. So you run the movie backwards. He thinks it started up in Alaska. And then it's just going to go all the way around, and it's going to just start erupting. It's just hypersonic water just shooting up with tremendous force. And now you got two 60-mile cliffs, right? And on Earth, you can only have a cliff 5 miles high because that it's going to crush what's underneath. It can't support over 5 miles. So now you got 60 miles cliffs, and there's 2 of them. And they keep eroding, and you'll notice that it's eroding on 2 sides of the granite. On the bottom of the granite and on the side of the granite, but only one side of the basalt, on top of the basalt. And that's why I believe that there was the ratio of 65 parts granite to 35 parts basalt. And that's where you're going to get all the sedimentary rock all over the layers. And then you get all this sediment there. Well, how come they're sorted so well, like at the Grand Canyon? It's just these pure layers, knife edge. And Walt Brown says that, and Bob Enyart too, liquefaction. During the flood, there weren't any continents, so there's nothing to break up the tides. So you got these huge waves going across the continent. It could be 200 feet high. So there's 200 feet of water pushing down. That's a lot of pressure. That'll pop your ears, I suppose. And then when the trough goes by, the pressure is released. So the water comes out of the sand, and then the next wave pushes it down, and comes out, pushes it down, and that could sort it out. It's called liquefaction, and that's how you get layers all over the Earth. Okay, so now the 2 60-mile cliffs are getting wider and wider and wider and wider and wider apart. And then pretty soon there's nothing pushing down on the mantle. So the mantle bulges and the continent starts sliding. And that's why the Earth's crust is missing in the mid-Atlantic. It slid away, it eroded away, and then it slid away, and then the continents fit perfectly. They show you Pangea, but there's a lot of problems with that. They have to shrink Africa 30-some%. They have to twist things, no Central America. But if you just line up the continents around the mid-oceanic ridge and allow a few hundred miles for erosion, now it fits perfectly. So that's why the crust is missing in the mid-Atlantic, and now you got these continents sliding on supercritical water, which I think is 30-some% has more viscosity than regular water. So it's just grease lightning. The continents are sliding, and it's like if you had a train track and you lift it up, the train's going to start rolling. And that's what's happening with the continents. You got North America and South America going to the west, and you got Africa and Europe going to the east, and they keep going until they meet resistance or run out of water. And then they're going to buckle up. It's like a rug going into a wall. It's going to buckle. And that's how the mountains formed. That's why the major mountain ranges are parallel to the mid-Atlantic ridge. Okay, and you'll notice that the Rockies are twice as wide as the Andes, and I think it's because the Rockies slid over the mid-Atlantic ridge. And then there's a lot of friction there. There's just a lot of friction, a lot of heat, a lot of melted rock, a lot of lava, and it's going to make our coal and oil and metamorphic rock like the marble and the diamonds. And by the way, all that stuff has carbon-14 in it, proving that they're not millions of years old. If you find carbon-14 in anything, it's less than 100,000 years, and they find it all these things that are supposed to be millions of years old. And then you've got these folded mountains up in British Columbia, and these are layers. They're curved rocks, and you can't bend rock; it's going to break. I don't care how strong you are. And so what happened here is the layers of sediment were laid down, and then it buckled up while it was still moist, and then it turned to rock. That's how those were formed. And what force crushed the granite in the Gunnison Canyon? Well, a continent's sliding, and then it stops on this side, but this side is still going. So that's how you're going to be able to crush 50 miles of granite for that. I mean, that's a lot of pressure. And that's how it's going to crush in Grand Canyon, the Vishnu schist. And in the Grand Canyon, as it's crushing, it buckles a little bit. So now you got slanted lines, slanted layers on top of the buckled Vishnu schist, but there's still some stuff that's sliding horizontally. So that's how you get flat layers on top of slanted layers in the Grand Canyon. And some of this stuff was sliding. The sandstone, I believe, turns into quartzite. And this chunk of quartzite got lifted up in the mud and got lifted up into a layer of sedimentary rock where it still sits today. And it's, I think, one of the evolutionists' worst nightmares. How are you going to explain that over millions of years? Because it came from the layer down the bottom right, and it's up there, 5 to 10 tons. And there's the coordinates of it, if you ever want to go look. And it's facing north, I believe. All right, so now, how do plateaus form? Remember that double-ended mystery? Well, the mountains rose up, so now you've got a big mass on a small base, and it sinks in. Well, if something sinks in, something's got to move up. So it's the mountain sunk down, the plateaus came up beside it. It's as it's squishing down, it has to force the magma somewhere. It can't go down, and so it forces it out to the side. The mechanism for and then it block faults at the weak points and goes up. So the mechanism is hydraulic lifting, and the force is gravity. The gravity of the mountains bringing it down squirts out the lava to the sides, and that puts enough pressure on those side ones to break up and go. And they aren't going to all go up at once. They're going to go up one at a time, the weakest ones first. And the lava might get squeezed between the cracks. And the lava gets to the top of the surface. So now you got hard stuff on the sediment, soft sediment. And if a bunch of water comes through with the great denudation, you got to remove 1,000 feet of sediment before you can even think about cutting the Grand Canyon. And that's what happens here. All this water's coming through, and it doesn't take it all because it's covered by lava. And so then you end up with Red Butte, which is 1,000 feet of sediment capped with volcanic rock. So that's how you get. And guess what? It's close to the Grand Canyon. Okay, now I give a whole hour talk on the Grand Canyon, but here are the cliff notes. Why did it go through the plateau instead of around it? Bulging and cracking 3 times. Just remember that. We're going to go through 3 bulges and 3 cracks, and it's going to explain Grand Canyon perfectly. But the real force of it all is these 2 huge lakes, Grand Lake and Hopi Lake. They're on the the Colorado Plateau above the Colorado River. And there's enough water in there for 3 Great Lakes, and they're over a mile above sea level. So that's tremendous potential energy. And then once the Grand Lake starts overflowing its banks, it starts cutting down a V through this opter sediment, and it cuts down until it hits the hard Kaibab limestone. That's why I don't think it was right after the flood. It needed time for the limestone to become rock. And then it spreads out, it makes a funnel, and now there's nothing pushing down on the funnel, so the funnel bulges, that limestone bulges and cracks, and the water goes through the crack, and it undercuts Hopi Lake, which is even higher. And then Hopi Lake starts, now that waterfall, Walt Brown says it's probably 13 times higher than Niagara Falls and 100 times the water flow. And it's just sheet eroding everything on top of the Kaibab limestone. And pretty soon there's nothing pushing down on the Kaibab limestone, so it bulges, making that whole plateau, it bulges, and then it cracks. And then the river runs through the crack and cuts down until it hits the hard basement Vishnu schist, the hard basement rock, and it should get wider because the sedimentary rock is softer than the hard crystalline rock below, but it doesn't because there's nothing pushing down on the basement rock, so that bulges and cracks. And then the river runs through the crack. That's the inner gorge. And so 3 times bulging and cracking, you can explain Grand Canyon. And they've got 4 theories on their park website, and none of them work. So I submitted this one, but they didn't get back to me. So maybe you guys can submit it. And so Walt Brown, what he does, he's got these decision tables at the end of every chapter in this book. And it's just great, because that's how they do it in the military. If something goes wrong, well, what could have gone wrong? There's like 10 or 100 things that could go wrong. For this, there's probably 9 theories for the Grand Canyon, and there's probably 24 features for it. So the theories are on top, the features are on the sign, and then it's red, green, yellow, and red. If it explains it really well, it gets a green light. If it's really poorly, can't explain it at all, it gets a red. And if it's kind of, sort of, but a little weak, it gets a yellow. And you'll notice that Grand Canyon is green, or the hydroplate is green all the way down. And everybody else is red or yellow all the way down. And my brother-in-law was taking a class at St. Cloud State, and they were trying to figure, it was a geology class, and they were trying to figure out how Grand Canyon formed. And they spent a week on it. And they didn't have a theory that worked. And then on Friday, the professor said, there's a theory that we haven't talked about. Anybody know what it is? Kid raises his hand and said, no, it's flood. And the professor said, you're right, but we can't talk about it. Even though they'd have a theory that doesn't work, they won't look at a theory that could explain it. Okay, the mid-Atlantic ridge rises up. Okay, so again, if something rises up, something's got to go down. Remember, the mountains went down, so something had to go up. Well, conversely, if something rises up, something has to go in. The mid-oceanic ridge rises up, so what goes down? The Pacific Ocean. It gets sucked in, and that's where you get the Ring of Fire. And that's why all those volcanoes and trenches are in the Pacific Ocean, got sucked down, and all those volcanoes are there. And then also a whole continent got sunk down. Anybody ever heard of the 8th continent? Zealandia? And the 8th continent reveals its buried treasures, and it says that they found evidence of land-based fossils. So that was above the water at one time, and then it got sucked down. It's about the size of India, and all that you see now is New Zealand. Okay, and Walt Brown had predicted you're going to find granite in the Pacific Ocean. And there's granite in the Pacific Ocean. And then he's got that decision table again, comparing the hydroplate theory with the plate tectonics theory. Remember, plate tectonics, that's a godless theory. It's a secular theory. And the hydroplate theory is the Bible one. And it's green all the way down almost for the hydroplate, and it's red all the way down almost for the plate tectonics theory. Okay, and so then how do you get the submarine canyons? Well, all the water that was covering all the continents gush off the continents to fill in the Pacific Ocean and cuts the canyons in the continental shelves, and then the continents sink down and the oceans rise up and bury those canyons in water. So how did that happen on Greenland? Again, the water gushed off, cut the canyon, and then the ice age filled it up. Well, then how do you get the ice age? They can't figure it out according to nature. Well, to get an ice age, you need warm oceans and cold continents. You need warm oceans, so you get a lot of precipitation, but you need cold continents, so it's snow. And then you also need it to snow more than it melts year after year after year after year. Okay, so how do you get that? Warm oceans, well, all those volcanoes in the bottom of the Pacific, that's going to warm things up. Well, how do you get cold continents? Well, there's, the continents are higher, therefore colder. And also, you got those volcanoes going off, a lot more aerosols in the atmosphere. And that's going to keep the sun's heat from getting to the continents to warm them up. So 400 or 500 years of that, you got the ice age. And during that time, the volcanoes are slowing down and the ocean's cooling off, and then the atmosphere's clearing up, so there's more heat getting to the continents. And so 400 or 500 years to build up, and maybe 100 or 200 years, maybe 300 years for it to melt. And we're still melting today. Okay, and so how come you didn't have glaciers in Alaska? Well, it's because it came down as rain. It was close enough to the ocean, and maybe it was lower altitude, and Siberia came down as rain instead of snow, so it didn't get a glacier there. And then Lake Vostok, these lakes under 2 miles of ice, the same thing there. After the flood, every depression on Earth had water in it, and there were some depressions there in Antarctica, and so now the ice age comes, and now there's a race. Is it going to freeze the water to the bottom, or is there going to be enough snow on top to insulate it? Well, the snow won. Oh, and by the way, they found 91 new volcanoes beneath Antarctica's ice. So if they're freaking out over the glaciers melting, maybe it's those volcanoes. Maybe it's the sunspots. And I encourage people to watch our speaker last month we had at the Twin Cities Creation Science Association, Helmut Welke. Go into our YouTube channel, TCCSA. And at the 4720 mark, he talks about climate change. And he talks about the fraud that's happening there. And he makes some really bold statements like a war on carbon dioxide is a war against life. We need carbon dioxide for the plants. If we had more carbon dioxide, we'd have more food and we'd have less droughts. So again, we need to see both sides of the issue if we want to think. And a lot of times, we only see one side. And yeah. Okay, and so then what froze the mammoths? Okay, these temperate animals. How come they got so cold so fast that they froze one alive? How did that happen? That's the cold hail. Okay, the fountains of the Great Deep were going up with such tremendous force that it escaped our atmosphere and got super cold. And it got in the heat sink of outer space, it's really cold, and what's going up there? Water and ice and mud and rocks and carbon dioxide frozen is dry ice. And then the gravity grabs it and pulls it back down and buries those mammoths. flash freezes them in a temperate environment. So then you can still see their identifiable food in the stomach. And then it buries them under the ground in that frozen mud and hail. And then Noah's flood comes over it, and then the flood comes off. And Walt Brown, he's got that decision tree again. You know, which theory explains it the best? Again, the hydroplate theory, way to the left, mainly green, and everybody else, mainly red and yellow. And you can go through and analyze it yourself. And then, okay, so that's how it froze them in a temperate environment. But how come they didn't thaw out? That brings us to the big roll. See, the mountains on the northern hemisphere and the southern hemisphere pretty much cancel out, except for the Himalayas. Whoops, except for the Himalayas. There's a red mark on, or there's a red weight on that bowling ball. And so it was spinning at the top, and if there's a big mass, a big weight on the spinning object, it's going to try and get to the side. And therefore something to the, it's on top, it goes to the side, therefore something on the side goes to the top. And therefore, Mammothville, temperate environment, where there's a lot of food and water, they're getting all fat and sassy, the big roll comes and moves them up to Mammoth Chill, where they never thaw out. They're in the permafrost. And we find them in the spring as the rivers erode. Oh, and by the way, that's how tropical palm tree got moved down to Antarctica. And that's how you get the palm trees down there. It was on the side, but then as the earth rolled, it went to the bottom. And that's also how you get the snakes, tortoises, alligators, badgers, and shrews in the Arctic Circle. They didn't live there. That's just where they ended up after it rolled. And if it did happen, wouldn't it leave a mark on the earth? And the answer is yeah, it did. The earth isn't round, there's a bulge at the equator. And as the earth rolled through that bulge, it cracked it. 3,100 miles. And so my guess is the Himalayas were formed 3,100 miles farther north, and something in the Arctic right now is 3,100 miles south at one time. Just my guess. And there you see it, perfectly straight, pointed directly at the Himalayas, just like the theory would explain. Okay, and how come the Petrified Forest National Monument? Notice that's in the bottom of Hopi Lake. Okay, a lot of those in that grand circle, you got Zion and Bryce and Canyonlands and Monument Valley, all those weird features around that area. But Petrified Forest, Walt Brown says that that lake had a lot of silica in it. And the silica, it precipitates out of the solution when it cools off, so it had to go somewhere, so it goes into the logs and petrifies it. And you apparently can do that in the lab in a matter of rapidly. Okay, and then Monument Valley, again, that's in the bottom of Grand Lake. And I'm not sure how deep it is there, but Grand Junction, Colorado, that would have been under 1,000 feet of water. And so that's a big lake. And what you don't see, if you were to dig down under all those mesas, buttes, and spires, you'd find 1,400 feet of sandstone, which means there was 1,400 feet of sand at one time when that was a lake. And as the lake drained, there wasn't any pressure keeping it into the sand, so it came to the surface. And as it came to the surface, it would erode stuff, and if there was something hard on top, it was just erode out the side. So that's how you get the mesas, buttes, and spires. That's the bottom of a lake that drained. And then what caused the inland seas? We're going to answer a lot of questions with one concept. What got the chondrules in the meteorites? Remember, high impact, rapid cooling. And how do you fuse past iron? And you could learn all that on Brian Nichols' Origin of Earth's Radioactivity. The Brian Nichols channel is one of the best if you want to understand a hydroplate. A lot of these graphics are his. He spends a lot of time making the graphics and a lot of time writing it out. He's an incredible writer. Just all this information, very logical and very, very, very well done. So I'm getting this information from him. Well, quartz, like I said, is made of 4 different things, and one of them is, this is granite, made of 4 different things. And again, the Earth's never been molten. I don't know if I mentioned this already, but it's made of feldspar, mica, and hornblende. They all got different specific densities, so if it was molten, they'd separate out into their densities. So granite's never been molten, therefore the Earth has never been molten, like the evolutionists say. But anyway, okay, so now quartz is very special. If you squish it or rip it apart, it's going to spark. They call it piezoelectric. Piezo pressure, and then electric is the spark. And so if you put it in tension, that's ripping it apart, it's going to spark. If you push it together, it's going to spark also, compression. And as those the hydroplates, as they're banging up and down, they're going to be buckling like this. So at the top of a buckle, it's going to be getting stretched and spark, and at the bottom, it's going to be getting compressed and spark. And they call all this fluttering. It's going to be going back and forth. And when like right there's a lot of pressure building up at the end. Then once it gets enough pressure, it's going to shoot up, and it's going to release the pressure, and then it's going to slam down. So it's going to keep on buckling and pressure like that. And so how do those chondrules form? Remember, they need high velocity collisions, and they need to quickly cool. Okay, well there's a high impact velocity collision right there when those 60 miles of granite come slamming down. That's a big collision, and it could Z-pinch or melt certain areas of the rock, and then it's going to get pushed to the side, and then it's going to get shot up into space and cool quickly. That's how you get the chondrules in space. Okay, how do you fuse past iron? See, on the supernova capability, it can get up to iron, that's not a problem, but then there's some problems with the Coulomb force or the strong force. You can listen to Brian Nickel to get that one straight. But they have this thing called Z-pinching, which can make all these different elements. They take a pure electrode material, it can be copper, silver, or one of 22 materials, and then hit it with a real hot dot. And I'm not smart enough to know how they did that, but what the result is 94 elements and super heavy elements, and it's the same ratio of elements as we find on Earth. But a lot of these are unstable. So they're going to be too proton heavy or too neutron heavy, and so they're going to decay into this valley of stability. Okay, and it has to do with plasma. When those sparks in the granite, it's like lightning. When lightning happens, there's a charge in the cloud and there's a charge on Earth, and when it gets big enough, there's going to be a spark that goes from one place to the other, and that's going to shear off the electrons, and that's going to make the plasma. And that's what's going to happen inside the granite. There's going to be plasma forming inside the granite, and in the thunderstorm, you hear the kaboom, it just resonates through there. But it doesn't really do that with granite so much, but there is a rebounding effect, and it just smashes all those atoms back together, making the heavier elements that decay into the valley of stability. And then some people say, well, there's not lightning in granite. Well, they must not have read the Smithsonian. Why do lights sometimes appear during an earthquake? Or mysterious flashing earthquake lights may be explained, or what causes eerie earthquake lights? So it does happen, and this theory explains it. And in the 9th edition, they've got a whole chapter on this. And Walt says you should be able to predict earthquakes based on disturbances in the ionosphere. He says that. But we need to get that 9th edition out there quick. But here's it says, how do you get Earth's radioactivity? And they compare the hydroplate theory with chemical evolution. And the hydroplate on the left is green all the way down, and chemical evolution is red almost all the way down. Okay, and so what caused the inland seas? As all these sparks and neutrons are going on and radioactivity, you might get some weak spots in the crust. And the crust is going to just explode there. And that's how you get the inland seas. It's just going to get a little weak and boom, and therefore the inland seas. And then you get these salt domes. As the water gushed off the Mississippi into the Gulf of Mexico, bringing all these sediments, it's going to bury all that salt, and that salt is more buoyant than the freshly laid down sediment, so it's going to go so far. And again, in August, I want to know how that happens. That's my main question. Okay, and then some of the stuff got shot up with such tremendous force that not only did it escape our atmosphere, it escaped our gravitational pull. So now you got rocks and mud and dry ice and water and ice out there like dirty snowballs flying around. What's been described as dirty snowballs in the, what? Comets, absolutely, comets. Walt Brown thinks that comets came from Earth. That's why Kevin Lee he actually accurately predicted that. And that's why you find stuff like water, salt, silicates, limestone, cubonite, all those things in a comet. Okay, and that's how cubonite, remember, formed in scalding hot water. Well, that's going to be the fountains of the great deep. The subterranean water chamber is super hot, and then it's going to just go up there and it's going to be rounded. And that's how the sea plankton got out into the outer space. It got shot up there when the fountains of the great deep erupted. And the comet close-up reveals a world of surprises. Remember those goosebumps and dinosaur eggs, the fast flow of water gets shot up there. And this one says there's a diversity of gases coming out of that comet. It's emitting mostly water in one part of it, which makes sense from the hydroplate. In other parts, its emissions are dominated by carbon dioxide, which makes sense from the hydroplate theory. No problem at all. And then they found organic molecules. And now they're going to say, see, the asteroids brought life to Earth. And it's like, no, Earth shot the life into outer space. And if you want to hear Kevin Lee talk about this, go into Rumble, the Hydroplate Conference, and or YouTube or hydroplate.com and listen to the Comet talk. When I was promoting this at St. Cloud State, I'd tell the professor, I went into the science departments telling her it was coming, I went into the president's office, invited her to tune in, and whenever I talked to somebody, and I'd say, if you can only listen to one of the talks, listen to the Comet talk. That's the one. Even before the Air Force professor, listen to the Comet talk. And listen, you go on this, the one on Rumble, listen at 22:15, where you're going to listen to Kevin Lee standing face to face with the NASA scientist in charge of the Stardust mission. He's going to get stuff from the comet back to Earth. And to paraphrase, Kevin Lee says, you're going to find stuff from the Earth in that comet. And the NASA professor says, no, we're going to find stuff from the Oort cloud in that comet. And they found stuff, from Earth. And so he was shocked. And then in 2016, and you can listen to this at 31:45 of that video, he emailed the same professor. And he said, if you try to redirect an asteroid, it'll work if it's a solid rock. But if it's just a bunch of boulders, it's going to fail. And guess what? It failed. There's 30-some boulders coming at us. So this hydroplate theory is very important. They're making catastrophic blunders because they're ignoring it. And you can listen to that. Also listen to it on Real Science Radio on YouTube or rsr.org on the radio. And Fred Williams, Doug McBurney do a great job. And you can expect. And I was so glad that you can hear it straight from him because he's got it all documented. And so he's been right, makes those accurate predictions. Nobody else was predicting they'd find stuff from the Earth in those comets. And then when he said they presented it, there were 600 scientists who just, their mouths dropped to the ground. It's like, how did that happen? But the hydroplate, no problem. And so this is the decision table for the origin of comets. And again, the hydroplate theory on the left is green almost all the way down, and there's some that are pretty green too. So it's something to look at. And how do asteroids get moons, and how do you get peanut-shaped asteroids? And how come they don't blow each other to pieces? And this one just came together just gently. It's just kissing it. How do you do that? Well, just the next time you play pool, just observe. Do those rocks or do those pool balls stick together, or do they go apart? Well, that's what's going to happen in outer space too. They're going to break apart. Just look at the rings of Saturn. They're not turning into moons. Look at the asteroid belt. They're not turning into planets. The way you get a moon and a peanut-shaped asteroid is if they're coming from the same spot at the same velocity and they come slowly together, and then they can get a moon. And this is a peanut-shaped asteroid, 624 Hector, has a moon. It's a contact binary, a peanut shape, plus it has a moon. They can't explain either one of them. But the hydroplate, it's not a big deal. We can answer that mystery. Okay, so now how come most of the comets go in the direction of the Earth? So just think the Earth is a train going 100 miles an hour, and you shoot something off at 50 miles an hour. It doesn't matter which way you shoot it, it's going to keep going in the same direction as the Earth. Now let's say you shoot it out at 150 miles an hour. Now there's going to become, if you're shooting it backwards, it's going to keep going that direction. But now let's say you shoot it out at 500 miles an hour. It doesn't matter which way you shoot it, it's going that way. And that's how you can explain the weird orbit that puzzles the scientists, according to space.com. That chunk of ice orbiting the sun in the wrong direction, based on their blind chance perspective of the universe, it's the wrong direction, but not the accurate perspective of the universe with the creator and the hydroplate. It's perfectly fine, no problem. And it says, the orbit of Nico is unusual that it's nearly perpendicular to the plane of the solar system. More than that, it's orbiting in the opposite direction of most solar system bodies. Furthermore, there are a few bodies that share the same orbital plane, with some orbiting prograde, that's with the Earth, and retrograde against the Earth. Okay, that was unexpected. Yeah, when your perspective of the past is wrong, it's unexpected. But if your perspective of the past is right, it's not a big deal. And that's what the professor from the U.S. Air Force Academy did the talk on at the Hydroplate Conference, Trans-Neptune Objects. And he gets published in secular journals. And he says, hey, the math shows that the comets came from the inner solar system. And he was right. This theory is just knocking it out of the park. And you got this decision table again for the origin of trans-Neptune objects. And the hydroplate is green almost all the way down. And the evolution of the solar system is red almost all the way down. So there's a lot of things that are pointing strongly to the creation model, okay, to the hydroplate model. Well, wouldn't it leave a mark on the moon if that happened? All that stuff shooting out? Well, yeah, it did. That's why there's low density on the far side and high density on the near side. You got all these the lava flows on the near side, and the far side doesn't. They call them mass cons. How come you got mass cons on the near side, high density things there? And then that's how you got the moon. The oldest earth rock is on the moon, made in a water-rich environment. Oh yeah, that makes sense. Crystallized and down there, and then the moon is rusting. Yeah, that's because there was oxygen on the earth that went up there with the rocks. And very puzzling. And then this is what I really like. Creation.com did this article called Flood. And they described all these flood models from around the world. And Scandinavia's one is fascinating. It describes the hydroplate perfectly. He says, the axis on the earth was shaken from its roots to the topmost branches. Mountains crumbled or split from top to bottom. Men were driven from their hearths, and the human race was swept from the surface of the earth. The earth itself was beginning to lose its shape. Already the stars were coming adrift in the sky and falling into the gaping void. Flames spurted among fissures. That's the lightning in the granite and in the rocks. Spurted in fissures in the rock. Everywhere there was hissing of steam. That's the supercritical water coming up. All living things, all plant life were blotted out. And now all the rivers, all the seas rose and overflowed from every side. Waves lashed against waves. They swelled and boiled and slowly covered all things. The earth sank beneath the seas. Then slowly the earth emerged from the waters. Mountains rose anew. I think that describes the hydroplate perfectly. Okay, and again, I'm not impressed with Walt because he's got letters behind his name. I'm impressed because he makes accurate predictions. And here's some of his accurate predictions. He predicted that beneath major mountains are large volumes of pooled salt water, confirmed. The crystalline rock under Gibraltar and other places would be V-shaped, confirmed. And their soil and erosion channels on Mars will contain trace amounts of Earth-like soluble components, confirmed. Some comets, asteroids, and meteors will be found to be made of crystalline material and forged in extreme heat, confirmed, like cubonite. And some large and near parabolic comets, as they fall towards the Earth, the solar system for the first time, will have moons, confirmed. And that's a hard one. A hard one for those secularists. Asteroids are rock piles, confirmed. And then most rocks and pebbles will be rounded, confirmed. And then also Planet X will not be found in the next 5 years by January 2021 because it does not exist. So he's making very specific predictions that can happen in your lifetime. And then bones and other organic remains will contain carbon-14, confirmed. And we find there's, because what did she say? That person, the professor said, I don't believe there's water under the oceans. You know, that she didn't believe the assumption. And I said, why not? There's water under the ocean today. You got these black smokers coming up at 800 some degrees. And Job talked about the springs of the sea. And we didn't find out about them until 1977. So the Bible's always right when it talks about science. And this is one of the footnotes from the 9th edition. And I tell you what, just do some surfing from idea to idea. It is so fun. And it says, down at the bottom of the Atlantic Ocean is the hottest water on Earth in a supercritical state never seen before. And Walt Brown goes on to say how that couldn't happen without this theory. And this says, oh yeah, and also supercritical is seen jetting up from the floor of the Gulf of Mexico. I just threw that in there so you guys might see it someday, I don't know. Okay, so we have all these unanswered questions, all these they're always surprised, all these mysteries. And yet with one theory, we answer them all. If you don't want to be confused, look at the hydroplate theory. And I'm going to kind of start winding down. Widespread belief systems seldom change when frequently reinforced by influential institutions such as universities, medias, and even creation institutions, and the scientific and intellectual elite. But when vast numbers of people realize they have been misled, an intellectual revolution begins. Okay, and that's my goal. I'm trying to reach a vast number of people and say, we've been misled from our government institutions. We've been misled. And so then we can have a scientific revolution. And observers of the revolution should note which side avoids a rational scientific debate. And that'd be the evolutionists. It's hard to find them to step up to the microphone. And other ones too, you know. And so, oh yeah, I got this email one time. So I love this here. I love talking about it. Seems like everybody I meet wants to talk about it, so we talk about it. And I got this email. It says, my best friend is Joe. And I wanted to reach out and let you know I've been praying for Joe to come to know God for quite a while. I've been praying that God would send Christian men into his life and have real conversations with him. Specifically, I've been praying that God would send intelligent Christian clients who would talk to him. Brian, you were an answer to prayer. Your conversation with Joe has opened his mind. I believe he's been watching your videos a bit because he shared one with me. And I emailed her back and said, thank you so much for the encouraging words, but I'm really curious. I got over 100 videos out there. Which one did he send to you? And I was shocked when she sent me, this is what he sent to her. You know, a 5-minute, or I got to speak to the Rotary Club. I had 20 minutes. So I squeezed an hour talk into 20 minutes. And this is during COVID, so there's no doors on the room, the hotel, or the restaurant room, so there's a lot of background noise. So I tried to edit it out, and it doesn't work, so it's rather poor audio. But it made me realize it's not the quality of the audio, it's the content of the audio. And so this is again, the hydroplate theory. And Walt Brown goes on to say, question everything yourself, starting with this book. Question everything, and I mean everything. See both sides of the issue before you believe anything. And you can get this book for $50 right over there, and also you can get it online for free. Go into Real Science or rsr.org/HPT. You're going to see the cover of this book. Go right underneath the cover. It's going to say 9th edition, and you can download that for free, and you should, because the internet could be taken down at the drop of the hat. And then also on that same site, you can listen to Walt Brown Week. That's what covered in the details for me. And also, let's see, what else? The Walt Brown controversy. You might be thinking, man, this is a great theory. How come I haven't heard about it? Well, there's a reason you haven't heard about it. You can listen to Jane Albright. She critiques all the flood models, and she talks about why you haven't heard about it. And it's really a sad commentary on Christianity, I believe. Okay, and then this is the hydroplate protocol. Okay, go into rsr.org/answers, and you're going to see all the published criticisms of this theory. And you're going to see the YouTube criticisms of this theory. And then you're going to see how we answer those objections. Okay, so wouldn't it be neat if evolution would do that? Hey, here are the published criticisms of this theory. You can get all this on one website. So you have all the information, so then you can think for itself. And yeah, the hydroplate could be wrong. It could be. You know, I'm not married to it. But I think the framework, it might be wrong in one or two areas, but I think the framework's pretty solid, making all those accurate predictions. And I encourage also people to go onto Brian Nichols' website. This is on YouTube, and also Real Science Radio, and again, the Jane Albright one. So with that, I'm just going to leave that up for now. I got 2 minutes over. You can most switch computers. And let's see. Any questions while we're doing this? Those are oh yes, and again, thank you to Frank for allowing this. I appreciate that. Thank you for Grace Baptist for allowing us to be here. And we just pray that it would be used for God's glory.
Okay, thank you.